before, we stand.
Yeah, that's true. Right?
All right. I think it's about time we get started. Thank you all for joining the keynote and panel section here for the exhibition Altering Nature. I'm Wang, the curator of this exhibition. And today we will focus on the theme, exploring the practical significance of computational art. So firstly, I will invite 3 speakers to give us the 10 minutes keynote presentation, followed by a 30-minute panel discussion. At last, I will leave 10 minutes for everyone to engage with our guests. So, firstly, let's welcome Professor Theo, Papatheodorou. He's a professor of practice in the computational media and art at Hong Kong UST in Guangzhou. And today, his presentation is titled, How Computational Art Reveals New Worlds. Welcome, Theo.
Thank you very much. Hello, thank you very much for making the trip all the way from the gallery space. Yeah, my name is Theo, as I said, as our curator said, and I'm a professor at HKUST. Ziwei asked me to give a talk, and it was a very busy week last week and this week, and I debated whether to give it or not. But Ziwei came here. I know Ziwei from 2019. I was teaching her. I was a professor at Goldsmiths in the University of London. And when she came here in 2020 or something like that, Huamin, Professor Chu, asked for a list of names that the university should approach, and she gave my name. And the rest is history. I am here in China because of Ziwei. So it's very difficult for me to say no to her, because my whole life changed. My children speak Chinese. I'm here because of Ziwei. So I wanted to give, she said that there's going to be people in the audience. I see a lot of familiar faces. And she told me that there are going to be a lot of lay people in the audience, so it would be good to give an introduction to computational art. But I thought I'd give it with a bit of an angle about how it helps us discover things. That computational art helps us reveal new worlds. So this started from the early computing pioneers like Vera Molnar, where they first got their hands, the first people to get their hands on a computer to make art, and for them it was a blank slate. And it allowed them to do things like this, things that, and many iterations of this it has. For example, things that are perhaps nearly impossible to do by hand. And they were exploring also with optical art, the optical art movement and so on. They were exploring what is visually possible. So it was about new forms, new aesthetics, and concepts. And it didn't come without some skepticism. Is it art, they said? How could the computer, with these cold processes, this precision that it has, how could it make something that's warm, that speaks to the heart, let's say, like a human artist? And they were saying it's not about mimicry. It's a whole new art form. It's about exploring the computer's unique strengths. And what's that? That's the ability to do many experiments, to produce generative art, to explore also complexity through simple rules. Like here we have like 4 sides of a square, and she's trying to make something visually interesting just by superimposing many of them and tweaking the angles. How many rules do you need in order to make something engaging, meaningful? And she's subverting this precision that the computer comes with. The computer will always do what you ask it to do. We have to try really hard to subvert that precision in order to make things that look perhaps a little bit organic. And part of that is using chance and randomness as creative partners. So in generative art, for example, and this is an example, I often show this example. Richard Dawkins's famous books were republished about 4 or 5 years ago, and the Penguin, in order to honor the publication, the famous books around the world, in order to honor the publication, each copy of the book had a unique generative organism. So these are organisms that Dawkins was one of the first people to also use computers in order to make evolutionary algorithms and so on, and to prove certain theories. So these were the organisms that he developed, for example, for the selfish gene in the 70s. And they reprinted them, and each organism got its unique cover. Generative art. And as artists, as computational artists, we often hand some of that control that a traditional artist has to the machine. And we embrace this randomness and chaos. And we can create infinite variations. So Field.io, a design studio in London, in order to celebrate the annual catalog, paper catalog of their client, each catalog had a unique cover. And this creates, of course, this setting these rules and letting them go wild creates unpredictable results. Casey Rias here that I'm showing, one of the creators, one of the two creators of processing, where a lot of other languages that artists use is based on, was saying that often the rules he sets create things that surprise even him. As artists, making something that surprises even the artist. And this allows us to escape our taste biases. If I like something that's, I like round vases, and I'm always making round vases, but randomness and chance allows me to jump in another part of the space and explore square vases and say, oh, you know what, I'm gonna now explore this space. It's about exploring the entire space of possibilities as artists. And of course nowadays with AI, we're turning the whole question on its head. It's not just an extension of the artist, like a chisel, but all of a sudden the chisel seems to have a mind on its own and moving and create things on its own. And it challenges, the new computational art challenges the idea of authorship itself. This is an early example from the 70s, seminally created a lot of discussions. It was what we would call today AI, but at the time, it was not using any of the techniques that you are using in the classroom or in your practices. It was using simple heuristic rules because that's what AI was at the time. But still, the results were surprising, were nothing like the artist Cohen, this computational artist from the University of California, San Diego, and would have created. And the debate was raging, whether who is the artist here. And we have examples like this, Edmond de Bellamy, that was sold for almost $500,000 in Sotheby's a few years back. And the debate continues, is AI truly creative, or is it just mimicking the training data? So we are using machines to explore the idea, the definition of creativity itself. We're turning the question, it's reshaping what it means to be an artist. And there are moments in history, in art history, where we were in the same place with photography, for example, where they were saying, is a photographer really an artist, or is it just a technician of a machine? Or ready-made with Duchamp saying this is the fountain, and completely turning art on its head by saying it's the idea, it's the concept, it doesn't have to do always about craftsmanship. And we have also unique attitudes inside the algorithms by feeding them specific data, but the data diet, if you will, they have a certain aesthetic. Mario Klingelmann's work there, using historical portraits, and they have, and GANs, adversarial neural networks, that have a particular aesthetic. So that's nowhere better seen as, I'm Greek, nowhere better seen as in this video by Memo Acton, where the particular diet of images from the sea makes the neural network interpret everything it sees in a particular way. We're making machines see differently. And it's not about replicating reality. And of course, it's impossible not to make comparisons to how our own neural network in the brain is working. And thinking perhaps that we see things not as they are, but as we are. And of course, art, like the artworks that you have seen and you will see downstairs, are interactive, and that opens a whole new window. Like Refik Anadol's work using wind from Logan Airport in Boston and making visualizations like these from a year worth of data, helping us uncover a new dimension of reality, seeing data in a new way. Or this piece, one of my favorite pieces, Harvest by Julian Oliver. He did it in 2017. There was a lot of debate about the ethics of cryptocurrency and mining cryptocurrency and the effect that it has on the environment. Now the debate has shifted a little bit towards AI. But at the time of when that debate was really hot, he made this machine that was a wind turbine collecting, generating energy from wind in order to mine cryptocurrency to fund climate research, all in one installation called Harvest. And it goes beyond aesthetics. As you see, it becomes a catalyst for social change. So I'll close by saying that it's a mirror, it's a lens magnifying aspects of our existence, and it's not just about new aesthetics, it's not about just bringing new pictures, it's about engaging and understanding ourselves and the world. And the exhibition ALife that we saw today has a lot of these elements. Has like data is at the core of these generative cuts that they created, the data set, the data visualization. It's not about just aesthetics. It's about creating. Yes. It's about creating digital organisms that live in an artificial environment. And it's about blurring boundaries, biology, technology, data science, and of course, an existential exploration. Where do we fit in all this? Thank you very much.
Thank you so much, Theo. Thank you so much. And next, let's welcome researcher and media artist Ziwei. She is currently a PhD candidate in the CMA program, and her works and research primarily focus on biology, science, and utilizing virus media. She will share her insights altering nature with computational ALife visual arts. Welcome.
Okay, thanks everyone for coming. And also thanks for Theo's presentation. I know you are always busy and you are always treat me well. Okay, so like my presentation title will be the altering natures with the computational ALife visual art. And I can have like a short introduction of myself. So I am a media artist and a researcher, and my work and research is primarily focused on biology, science, and their impact on society, utilize various media. And also I'm engaged in the interdisciplinary studies of artificial life art, exploring the intersections of the art and technology with the bio as concept and the bioinformation as data. And also like my main focus is mainly exploring how to create new artificial systems to alter the nature, and also how the nature has been changed by the human activities. Okay, so maybe most of you have a question. What is the artificial life art? So let me give you some introduction. Art plus life equal to artificial life, which means the life made by man rather than the nature. So Lanton defined this word of artificial life in the 1987. The previous definitions was questioned by many people, including Lanton himself. Thus, he updates the definitions into the study of nature life, where nature is understood to include rather than to exclude human beings and their artifacts. The topic consistently attracts artists and scientists discovering the fundamental principle of life and trying to rethink the new life form in artificial systems. It is worth to mention that artificial life presents how people understanding nature in different ages. For example, from the cave painting to the mechanical dogs. And also, Ars Electronica is one of the most important media art festivals, also for the topic of the artificial life for years. With the theme Genetic Art, Artificial Life in the 1993, Artificial Intelligence, Another Eye in 2017. And it also has a new category named AI and Life Art in 2019. So artificial life not only investigates life as we know it, but also research the life as it might be. So I name it How to Understand the Nature and How Can We Create the New Life. So people are using the technology to synthesize or simulate the artificial life. And then we come to the concept part. So normally artificial life art can be divided into three categories: for the hardware and the wetware and the software. So based on the categories of the hard ALife art, so for example like the robotic art, and then it's the wet ALife art, for example like the bio art, and also the soft ALife art. So I will introduce what is the software ALife art looks like in the following part. And there's also some definitions about the computational art and design, which means use the computationals and algorithms to create work. Art is more about questioning and aiming to create awareness of the world around us. And my focus is more on the art area. So then we zoom in, come to the generative art, and also Theo mentioned some of the generative art before. So for the generative art, it can be seen as the process art. It's not just a finished prototype. Art is focused on exploring how to design the process, and it's starting with the painting and the sculpture. So the computational generative art is the artist use the computer to design the generative process. And it's need to mention the evolutionary art that Theo also mentioned before, like the Richard books. It's actually like the pioneers of the evolutionary art. And this kind of art leads at least 10 years of the main artificial life art research from the 90s. So firstly, artists design like a generative process, and also second, artists find a way to evaluate the generative prototype based on that and generate it again. Okay. So there's also some relationship between the artificial life and also the artificial intelligence. So obviously, both AI and ALife are artificial, and it's on the opposite of the nature. So from the definition, AI is earlier than ALife. But in the earlier definitions, the AI is the science and engineering of making intelligent machines. And the ALife is the life made by man rather than the nature. So however, following the questions in the science fiction, it is about the intelligence and the life. Sometimes intelligence comes from life. For example, in the movie Frankenstein. And also sometimes the intelligence can be separated from life. For example, the ghost in the shell. And so here is some like the overall view of the art, what is like the artificial life art. So basis on what Neil Oxman mentioned in the article, we can separate the gray circles into 4 subjects: the science, engineer, design, and art. So science is to explain and predict the world around us. And the engineer, I think most of you are familiar. And the 4th part can be like a clock. And it's different from each other. However, it can move in dynamic and transfer from the one to another. So in the art, we have like the computational art with the different media. As we can simply call it contemporary media art. And also, so here is like a big circles of the contemporary media art. Inside that, we have like the artificial life art. And we can separate the artificial life art into the hardware, webware, and the software. So for the software, we have like the computational generative art and the evolutionary art. So there's like the art like widely used in other areas, not only in like the artificial life thing. Okay, so here is that. So in my art creations and research, I'm more focused on the software ALife art. And also, I collaborate with my 2 supervisors, Professor Kangzhen and Professor Huang to conduct like a survey based on the artificial life art. So we analyze the different topics from different surveys in the artificial life art, AI, and bio art. And conclude like my classification criteria of the artificial life art. The first one is about the materials. So it's divided into the hardware, software, webware, and then it's in the software artificial life art. We can have like bio as concept and bio as data. And also second is the theme. So as I mentioned before, like I analyzed some artwork in my survey. So many of the artists in the artificial life art are doing these 2 things. The first one is like understanding nature, and the second one is creating new life. Also, the third one is about the technology. So here are some mainly about the bio-inspired technology. For example, like the genetic algorithms and the neural network. It is not coincident that artists use this technology to create their own work. So here is the overall views about like our taxonomy. So the color represents the different art themes, and some of them are half blue and half green. So, and also there's a little symbol to represent the different technologies. So we come to the artwork directly. So here we firstly come to the bio as concept. So I divided them into the individual creature, swarm, and computational ecosystem. So for the individual creature, I can use my own practice to illustrate. So mimicry is an artwork that explores the pseudo-environment loop systems in nature, and the artificial material organisms combining like the living flowers with projectors, webcams, and computer monitors. And the virtual insect on the screen is changing their colors based on the real environment. So we build it on the genetic algorithm with an evolutionary system to pick the good mimicry species and let them breeding mutations cross over to have a next generation of the species. So after the long time of the generations, you can observe that the virtual insect successfully mimics the nature. And So Danlu and I created this work, benefit game, Alien Ziwei Swarm. So this is like a game installation, explore the human activities and the Ziwei Swarm. So Danlu will explain it later. And after that, there is a localization artwork collaborate with Hong Kong Red Cross and the Plastic Ocean Foundation Hong Kong to explore the ecosystems in Taiwan. And also thanks Jason for introduce these two organizations. Yeah. So the audience can explore the Taiwan system with different agents, and Danlu will also discuss this work in details later. So then come to the BioS data. The first one is the visual data. So previously I mentioned some of the typical ALife work. So most of them are following the methodology of using the artistic interpretation to understanding nature and creating an artificial life object. So recently, with the development of the artificial intelligence technology, the artwork combined visual data is about the selection bias with the artist from the studying object to the creating the artificial life object. So for example, like using the visual data as the data set to generate new visuals. So in our work, hidden incidents of the current deficiency is an example. So we explore the ghost of life with the incidents caused by the pet food and generate 6,000 AI blend casts. So this is the exhibition view. And then is another series of this work, so the hidden incidents of the animal euthanasia. So we collaborate with the forensic experts to explore the euthanasia drug, pentobarbital. Each of the animals are AI generated, and we are using AI to reconstruct the life with the real data. So this is the exhibition view. So you can explore them in the library. So and it is a series of the work. We explore the hidden incidents of the pet food with the terran, melamine, and pentobarbital. So then come to the signal data. The input data can be the biosignal data, for example, the EEG data, EMG data. And the key question is how to deal with the biosignal data to express the art concept. The output can be any type of the visual platform, for example, 2D image, 3D sculptures, and the interactive installation. And our work in passive growth using the human GSR data and the past data to create the hybrid digital creatures. And each of the audience will create one hybrid creatures with the plant. The hybrid creatures will live, moving, and communicate in the digital environment. So here's the conclusion. Let's back to this image. So in the BioS concept, we have the artwork to explore the individual creatures mimicry, and the benefit game, Alien Ziwei Swarm, to explore the swarm behavior, and the ecos of Taiwan to explore the computational ecosystem. And these three artworks explore the artificial life art system. Then we have like the hidden incidents of the pet food to explore the visual data, and the empathic roles to explore the signal data. So if you want to know more about artificial life art, you can have a look at my survey. Yeah. And thanks a lot. That's it.
And our final speaker is researcher and game developer, Danlu. Danlu's primary research focuses on exploring the potential application of AI technology in game development. And this encompasses the application of AI technology to game agents and AI-based procedural content generation. So Danlu's topic is behind the scenes, harnessing technology to sculpt art in game development. Please welcome her.
So, hello everyone. Thank you for joining me today. My name is Danlu, and I'm excited to share with you some insights from my journey as a game developer collaborating with artists on various projects. In the next few minutes, we will explore the innovative technologies and creative processes that have shaped our work, focusing on key areas such as procedural content generation, the integration of diverse technologies through Unity, the magic of shaders in crafting visuals, and the implementation of intelligent agents using reinforcement learning. Each of these elements plays a crucial role in enhancing the gameplay experience, allowing us to create immersive and engaging environments. I hope to provide you with a glimpse behind the scenes of our development process and inspire you with the possibilities that arise when art and technology converge in game development. So let's embark on this journey together. First, I'll be delving into the fascinating world of procedural content generation, which involves the algorithmic creation of game content with limited or indirect user input. This technique has been pivotal across many of our projects, allowing us to generate diverse and dynamic content effectively. So let's start with traditional PCG techniques. These include methods like L systems, which are used for simulating the growth processes of plant structures, and the graph grammars, which help in creating complex, scalable structures. An example from our own work is the Band-Fit game, where we generated fungi morphology inspired by real biological structures. This was achieved through a rule-based PCG algorithm that constructs the fungi by recursively combining key structure components, ensuring both biological accuracy and natural diversity. Moving on to AI-driven PCG. This new approach integrates machine learning to enhance and diversify content generation. For instance, in the Bentley game, we used a multi-layer perceptual model to shape seaweed based on real-world agriculture data, considering factors like water temperature and salinity. This approach allows us to simulate realistic and ecologically accurate seaweed shapes. Also, in our Turing project, we utilize the generative adversarial networks to create the appearance of blind cats. And in the Papatheodorou project, we explored the advanced 3D model generation using AI-driven techniques such as text-to-mesh and image-to-mesh. Now let's explore how Unity serves as the core of our projects, bridging various technologies to create cohesive experiences. Unity is our primary development platform, yet the diverse nature of our projects often requires us to integrate different systems seamlessly. Consider our Papatheodorou project, where we need real-time communication between a web front-end and Unity. To achieve this, we implemented a WebSocket server locally. This setup allows the web application to send messages to Unity, enabling interactive elements on the web page to reflect changes in real time within the Unity environment. By establishing a WebSocket connection, we facilitate bi-directional communication, ensuring that both systems can exchange data effectively. In addition, in our Empathy Growth project, we integrated an affective computing model which runs in Python environment. Here, we use the TCP sockets to enable data transmission between Unity and Python script. The Unity code runs a separate thread that listens for incoming data, ensuring that the application remains responsive while processing information. Also, in many of our works, we use different kind of memboards. For example, in both Benefit Game and Empathy Growth, we opt for wired connections using serial ports to ensure stability and reliability. Next, let's delve into the magic of shaders and their important role in crafting visuals for our project. A shader is a computer program that calculates the appropriate levels of light, darkness, and color, etc., etc. During the rendering of a scene, they are essential for enhancing the aesthetic quality of our games, creating immersive environments, and conveying important gameplay information. In our empathy growth work, we employ the remarching, a technique that allows us to achieve smooth blending effects between objects. Remarching works by casting rays from the camera into the scene and calculating intersections with surface, enabling us to create visually appealing transitions and depth. In the bandit game, shaders were utilized to simulate rot disease on seaweed blades, visually representing the impact of parasitic oomices. We implemented a gradient noise to create random organic patterns of decay on the seaweed. In Papatheodorou project, we applied toon shading techniques to create edge highlights on 3D models. This method not only enhances the visual appeal, but also serves a functional purpose by differentiating between poison animals and source animals through distinct visual cues. Now, let's explore the concept of reinforcement learning and its application in training intelligent game agents. Reinforcement learning is a machine learning paradigm where agents learn to make decisions by interacting with their environment. They receive rewards or penalties based on their actions, allow them to optimize their behavior over time. In our project, Echoes of Theo, we utilized the proximal policy optimization algorithm to train agents representing fishing boats and fish. The reward system we implemented is crucial for guide their behavior. When a fish boat successfully catches fish, it receives positive rewards. However, if the boat engages in overfishing, leading to ecological damage, then it incurs negative rewards, or the so-called punishments. For the fish agents, survival results in increased rewards, while prolonged starvation leads to penalties. This setup creates a dynamic learning environment where agents must adapt their strategies to maximize their rewards while considering the ecological balance. By employing reinforcement learning, we move beyond traditional methods like behavior trees, which require predefined rules for agent actions. Instead, our agent can learn and adapt to complex conditions, making them more responsive to the game's evolving scenarios and challenges. Yeah, that's it. Thank you.
Okay, thank you, Danlu. And thank you all for your insightful keynote presentation. Professor Theo introduced us how computational art can reveal new words, emphasizing the transformative power of this medium. And Ziwei shared her perspective from computational ALife visual art, highlighting the intersections of technology and ecology. And Danlu took us behind the scenes, showcasing the progress in creating computational art. Now let's come into the panel discussion of the theme. And our panel discussion is the theme is exploring the practical significance of the computational art. So this theme is particularly relevant as CMA and EMC disciplines established by two thinkers. Our panel aims to address the challenges and opportunities in education, research, and practice within this field. So, as our arrange the space of our panel, I want to introduce our four speakers, Professor Anyi. Welcome. Anyi is an assistant professor in the AMC and EMIA at the Academy of Interdisciplinary Studies. His research focuses on developing reliable, steerable, and explainable human-centered AI for creativity, art, and film, with a goal of fostering collaborative intelligence between AI and humans to enhance creativity and productivity. Welcome again. 那我的灯呢？我坐中间不合适，你们俩往这样坐，你们俩往这样坐，我右边好。Okay. Thank you all. Still stay here. Here is the first question. I think it's for Professor Anyi and Professor Theo. We know you are doing the education in universities, and the first question is how do you view the educating practice of computational art or about computational art, and what challenges or new insights have you encountered? So maybe Professor Theo will answer this question first.
Yeah.
Thank you.
Yeah, thanks for the nice introduction, and thanks again for this wonderful exhibition and also bringing us together. So I also teach the AI for image and video creation at this campus for this interdisciplinary school. So firstly, I would say, yeah, we are educating people, right? Although nowadays, right, even when we do generative AI, it looks like we are kind of like teaching machines, right, to create, to whatever. But I think that the first and foremost is always about the teaching. Is like we teach students, we teach people actually to think, to create, to have these tools to enable them to fulfill their goals, to reach their intentions. Because I think a lot of like the exhibitions, all the visual content I see here today, or even I see at other museums, and also I think the content always coming out from the experience of the creators. So I think the purpose of education is like to teach like students, help them to have more ways to experience the world, to experience the love, the nature, the life, and then they have their own ways, equipping them with their own ways to reach their own intentions, and in their own ways to satisfying their own requirements. And then they will first create things they personally love, and then they will create things they love to share with their friends, with the community. So I think through this process, it's like more about like equipping them with skills, and then like get them hands dirty, like providing them more different perspectives into this domain.
Okay, thank you. It's a beautiful answer. Yeah. So what about Professor?
Yeah, I'll focus maybe on one of the challenges, especially I'll focus also particularly in the kind of students we have in HKUST, both campuses are quite similar. In the students focus a lot on perhaps technical execution or code, and what's often lacking in projects that they're working on is a little bit more of the concept, the thought, the why. And the challenge for me as an educator is that I can't tell you, I've been teaching since 2011. If I had to write on a piece of paper what I should do in order, one should do in order to teach them how to make better art, I can't really tell you what it is. You just have to set the right conditions in the classroom, and as you often hear, like with art, it's hard to describe what is good, but when you see it, you see it. You know, so you have to create the right, let's say, atmosphere in the class, and to give them the right tools, in order and a healthy diet of other artworks to see, in order for them to start becoming better at finding that golden nugget that is behind the good artwork. I find that always quite challenging in the classroom.
Okay, thank you. One more question I just about it. Because our audience today, I see lots of the audiences that our classmates from AMC and CMA discipline. So what kinds of things you want to tell them? The most important thing to study or researching is interdisciplinary research topic.
Thanks for the question, and also what Professor Theo said. And I think, I also encountered, echoes me some similar difficulties a lot of students may encounter. It's what is the right tools, because some students, they can write Python, right? They can write code. Some students, they cannot, have different backgrounds. But I think, so it's the challenges in this interdisciplinary studies is we've got to master both technology and art. We can also say it's a suffering from the two sides together. So, but I think whatever we want to create codes or create exhibition or some image or videos, the key is always about your own passions. It's always about your own experience. You are passionate about creating these codes to create something that you personally love, you want to share with others. Because there is always will be, tools, because I'm working on computer science in HCI, there will always be different levels of tools, to provide an appropriate controls, right? For example, some people can interact with code, some people can interact with some a user interface, right? So there will always be tools, and people will be working on that. But the key important thing is always about your own experience, your own story, and then you can find appropriate tools to fulfill this goal.
And I'll say something maybe a little bit controversial, especially in China, is in that I always have red flags going up when students say, I want to do a project about cultural heritage. I'm a little bit tired of cultural heritage. Cultural heritage, for reasons that everybody can understand why, is a safe topic. You turn the camera, you look in the glorious past, which you have a glorious past, and you don't think very much about the present or the future. It's important to turn the camera the other way around and look a little bit what's going on around today and what are the possibilities for the future, and make art that is about these questions. Like what the work that we saw today have to do about ecology as well. These are problems that concern us today. Leave the ancestors where they are, resting. And if you must, I agree with you that it has to be your passion. Sometimes students come to me and they say, I want to do an AI project, Chinese opera. Do you like Chinese opera? You have to love it. You have to study. You have to know it inside out, and then say, okay, now I'm gonna do a project on Chinese opera with AI. Don't just give me AI, marmalade on top of the Chinese opera. You have to feel it.
Thank you. And I have a question to all of you. How many of you study on the cultural heritage? Is anyone?
Raise your red flag.
And how many of you study by your passion and your love, right now?
And the works, the people that I saw raise their hands, I've seen the works, and they are works that are interesting. They have been shown in SIGGRAPH. of the moment.
And yeah, this is a very good beginning of the panel, I think. And thank you both for your wonderful insights from the applications of this. And now turning to research and create work, and especially for the cooperating. So I think maybe all the audience want to know how to begin to work collaborating about the research work, our what is the beginning and why you want to choose the other one to work with.
Okay, number. So back to the beginning. At that time, I didn't have a supervisor, so the school assigned me to Professor Zhang, and that's quite a lucky experience. And in Professor Zhang's group, I meet Ziwei, and Ziwei was doing some group project about MFE, and she's looking for someone willing to help her. And at that time, since I just joined the Professor Zhang's group, I had nothing to do. So I think yes, of course we can try collaborating on this group project. And we spent 1 week working on that, and that paper gets accepted by Theo. And that's the beginning of our collaboration. Yes.
Okay.
And also it's a nice beginning because it allows us to use the PCG method to do the shape and also the shader to do the texture. So, and then we use it the same way to produce a lot of work. And you can see, like Danlu just mentioned. And also, so we always talk to each other when we are working, gossiping, just playing here. And I think we are really lucky to find each other. And also, I think another thing is like the same goal. So recently, like the same goal for me is kind of doing the research and art practice, and also for Danlu is also, and also paper. And also for Danlu is also doing the practice and the paper. So I think I will more focusing on the research of the artificial life using our own work, and Danlu will more focusing on like how to make the artificial life artwork with different kinds of technology. So I think we are in charge of a different role. So it will, so this makes us to collaborate in so many projects.
Yes, and also one more interesting point is that when we first collaborated with each other, at that time I haven't decided on my research direction, and but I am like forced to do PQE like very soon. So I asked Ziwei because Ziwei already passed the PQE, and Ziwei told me how to find the papers and how to summarize those papers, how to classify them, and yes, this will help I need to pass the PQE. And after I decided that my research interest should be around computer information generation by machine learning, I suddenly noticed that there are like many overlapping topics like between my research area and the research area, and there are like many papers that are both in her survey, PQE survey, and in my PQE survey. So that's like a
worked this summer on a project with somebody. It was an ex-student of mine said, oh, you know, my boyfriend is very good, he's a genius, blah, blah, blah. You should meet him online. I met him online, we clicked, it was very nice, we had interesting conversations. And we said, okay, let's test the relationship by doing an art project together. And we started, and we had a nice idea together. It was actually mostly his originally, and I said, oh yeah, we fed it, and we grew it, and so on. And I thought, oh wow, I found somebody now new, all of a sudden, out of nowhere. It was a nightmare to work with him.
I want to hear that.
It was a nightmare because I said, okay, I'm gonna do this bit, and he was gonna do, like, he sat on a big thing, and he said, I'm gonna do this, and I said, okay, fine. And then we would meet again after like a few days, and then I realized, okay, I need to treat him like a PhD student, like on a deadline. Can we meet every 2 days, every day now? And every time it was this big thing, this monster that he was fighting, and he was not delivering little bits. You know, you have to deliver little bits. Okay, we have something, we have something. So slowly I started saying, okay, let me do this bit, and I was taking one bit. Let me do this bit, and slowly, but surely, I was basically doing the bigger part because we had a deadline. We wanted to submit it on the SIGGRAPH, and it was accepted later on. But it was the worst relationship I've ever had with a collaborator. I never want to see him again. Eventually, we were very courteous to each other. We were three working together with Jesse, a friend of mine from London, and eventually he sort of got the point, and he voluntarily removed himself. I immediately wrote to SIGGRAPH, we want to remove his name, and we cut all contacts, and I'm very glad. It's the best thing you can do is work with people. You cannot do it alone. Anything good that I have done is I have done it with other people that I met randomly. This happened not to work out, but I often say to Ziwei that one of maybe her strongest skills are a skill to collaborate, to meet people, because since I met her, she has been working with many people in order to do great work. Don't do it alone. It's much more fun to do it with people. You'll be much better. Sometimes it won't work, but you know, in the end, the sum is that you're gonna gain a lot from it.
Yeah, I really love all these stories, good stories, sad stories. Yeah, because stories is like to connect people, and also I think in projects is about this. So yeah, because I personally working on a lot of video production or we say create videos projects. Indeed, yeah, if you see the bad side, it's like if you suffer from the both, right? If you work on the technology, you want the people working on the story, can you change your story because my technology cannot achieve this? But the story, if you're working on the story side, you will complain like, oh, your technology sucks, even if it's published on a top tier conference. But it reminds me like a story about director Spielberg when he shot the movie about Jaws. So at that time, they got to invent the mechanical jaw, but that machine failed a lot of times. So a lot of the whole crew member, they have nothing to do on the beach, and they got to complain with each other. And the creation process is really suffered. But through that process, I think they spend more time on the story, on whether they could show the tense situations without showing that, I mean, the mechanical machines, right? And it finally turned out to be a success, right? But I want to say, like, the process is always about you find a balance, you got to sacrifice something, but I think ultimately, I would say to my student collaborators, it's like collaborators, humans, this is always the most important thing, right? Yeah, don't lose your friends, I mean, through this process. Do not break up with your other one, when you, yeah.
I just want you to talk about you never talk it in other panels. Yeah, so we have to go back to the serious problem next. Now, let's discuss what you see as the most valuable future research for the development of computational art. For others, this
Well, what my colleague is researching is very important, like the using AI as a tool for collaboration. That's the hottest thing right now, and it has some way to go because we could work a bit more on the interface, how we interface. ChatGPT, the reason it became so hot, GPT-3 existed. ChatGPT allowed this new way of talking to the GPT by having a chat interaction. There are new models coming out or iterations on models that allow you to use them in specific circumstances. Let's say a vision model that's for fashion, and being able to develop this further because a lot of the tools now are generative tools. But for artists especially, artists need to know their tools. So it's important for the research to continue in the explainability of these AI models. They are so complicated. I taught yesterday ChatGPT, I taught large language models to my class, and I opened up by saying, like, I don't understand. I understand bits and pieces. I don't know the whole pipeline. It's incredibly complicated, and there are research papers coming out where they are attempting to, they are theorizing about where information is stored, how does it learn, why is it as good as we see it is, because it's unpredictably good. You know, they didn't predict that it's going to be so good. So it's a black box at the moment for researchers, for computer scientists, and even darker black box for artists. But it's important for artists to know their own tools. So doing research that way into the explainability of AI, so that you understand your craft better. Why are the images of the cats with some artifacts in the eyes, for example, when I use guns? And so on. I think that's also an important area to look into.
Yeah, I really love this point, and because nowadays, like the AI, usually whatever ChatGPT, Stable Diffusion, or Flux models, whatever, I think its behaviors is always like this. It's like sometimes work, right? Sometimes doesn't. Sometimes we even don't know whether it works or not. So think about any, software we currently have. Think about Uber or Didi, right? If it works like this way, right? Sometimes you will find a driver, sometimes don't, sometimes you don't know. Then you will never use Uber or Didi. So the reliability should be always, the key part of the research and also the explainability, right? If it doesn't work, why it doesn't work. But I would also love to add one more point to this. It's about the control. Because nowadays, all the machines, they are kind of like an unpredictable black box. But sometimes I think some scholars, they also say, right, even humans is also unpredictable black box. But humans have a lot of ways, to explain why I do this. And you can also use text, right, to express your intentions to the other ones. So also I think similar to what happened about the machines, it's like you've got to have more ways to express, users' intentions. And the machines have to have a way to take that intention. And also along with that is about the controllabilities. But before this, we got to everybody know, I wanted to control, I wanted to have more controllabilities. But I think the key is about what controls on your own specific problems, right? It's definitely, I think, not always about text, right? Sometimes can be spatial control, sometimes can be some 3D controls. So I think this is the part, not only about understanding also the user's intention, and also to empower these intentions to the machines, and then enable them to fulfill the outputs.
Just to add one more point, it would be also good if we could have a little bit more multicultural machine learning models. I don't know how, for example, these large language models are in Chinese, but in Greek, it feels like they're, when I use ChatGPT for Greek, it feels like I'm using ChatGPT 2. It hasn't been fed enough Greek, it doesn't know enough about Greek culture, so it would be nice also if they were a bit more ecumenical, these models.
approach or appreciate computational art. Because like when I go to an art museum, I watch medieval art, or I can appreciate the writing or the drawings, wonderful. And for example, impressionist, I can still appreciate it. But when it comes to contemporary art, I really lose my mind. I don't know what I'm doing. But for computational art, is it designing for more people to appreciate, or is it still just becoming a game?
Thank you for your question, and your question is to
To the professors.
For me, I'll be brief so that we answer other questions. For me, I find that often the barrier to entry in computational art is quite high, and you don't have enough information there. You know, a painting is a painting. But I think, you know, researching a little bit more, for example, the work that they did downstairs with the evolved organisms. For me, when I first read about evolution and making these little organisms in the computer, it was fascinating. What I can simulate, you know, the creation of an environment. What does this mean? Can they have children together? How can a drawing have children with another drawing to create a new drawing using evolutionary mechanisms? So knowing a bit more about what you see will help you. You know, studying a bit before going to the exhibition. Often what I do sometimes is I take a picture of the description and I say, explain it to a 10-year-old. ChatGPT, I say. Because often very esoteric, difficult language to hide and to impress. And I say, explain it to my child. And I read it and I'm like, oh, okay, that's what it wants to do. And then I ask questions. And what does this mean? And what does it mean? In order to go a little bit deeper. Because the barrier to entry is a little bit high sometimes.
Yeah, thanks for the answer. And I would like to answer from two sides. One side is from the creator. Because we all know, like, although currently ChatGPT can write text, Stable Diffusion can generate pixels, but we always know, like, pixels is not equal to painting, right, images. Or we say, like, pixels is not equal to a good film or a good video. So the difference is always about the story. I mean, even echoing today, I know a lot of like behind-the-scenes stories behind these exhibitions. So the stories, or we say the culture side, is actually very important for any kind of like computational art, right? Which means like even when you present it, you cannot just show that kind of stuff, right? It's always about the stories behind that. From the viewers or from the audience side, I think it's like we always say like 1,000 audience will have 1,000 Hamlet, right? It's like your own personal experience about that. Whether this creation can echoing you some of your existing experience. I think this probably might be a perspective to your questions.
But to clarify, when I go to an exhibition, I don't understand 80% of the work. Just so that, and I'm supposed to be teaching this, and I don't understand it. It's very badly presented many times, very badly. So we are in the same boat.
So is the responsibility for the artist or curator?
For the curator. Because it's very, you know, sometimes there's too much text and going into terms. Why don't you give us something to, like today we went to the Palace Museum here in Hong Kong. I was amazed. It was simple. It was everyday experiences. This is where they drank. This is how they did this. Bring it down to earth, to me, to understand, not to impress your friends.
Personally, it's nothing.
Yeah.
Okay, we can only open one question left.
Hello. So first, thank you for your insightful talks and discussion. And I'm also with computer science background, and I had some experience to work as a sponsor with some artists to let them convey some propaganda ideas in their artwork. But during this experience, I was asking myself, so are we going to really do this? Because I think art is about self-expression of the personalities of artists, right? But it seems weird we are trying to add some external requirements to their artwork. So I am curious about are we able to realize the balance between self-expression and some external requirements by exploiting technologies of maybe computational art. And also, my question comes in two dimensions. And the first dimension is for Professor Theo. That is about, is it really a good idea to reach a balance between self-expression and some external requirements such as propaganda ideas in art creation? And the second dimension is for Professor Anyi is, if this is meaningful, how to, such as by the technology means, how can we just add those external constraints to achieve it from AIPC model? Thank you.
Maybe for the professor?
Yeah.
Okay.
Do you want to start from the first question?
Maybe from the first.
Yeah.
When you say propaganda ideas, what do you mean from the state? What do you mean propaganda ideas? I didn't understand that.
Oh, or it may be conveying some ideas for products or for some policies. That, but about business or political uses.
It depends what you do the art for. If you have a client that is paying you, I mean, an artist could be working on making a new design for a car. If the artist is paying you, you also have to listen to the client requirements. If you are doing an exhibition like the artist here on stage, I think you should only be, listening to your head, and not involve any other, external requirements.
Yeah. Thanks for the your question. Yeah. I think I want to add to comment on this is like firstly I think creators or users, we never want something like a click a button and then generate something, right? We do not want a button to content, right? So which means among this process it's always about what the user intentions, or specifically corresponding to like the controls, as you said, like the constraints or those stuff to the technologies. For the technology side, I can answer you is like, you can either add on in the data, the model, the loss functions, the constraints. These are, the technique side, right? But I think before going to the technology side, it's always like you first got to understand like what the tools or the technology you develop is serving for what, right? So which also means like what the user intentions are here, what controls you want to have. Thank you.
Okay. So anything you want to add at the end of this panel? For some conclusion?
Maybe one advice for artists is to be bold and to go in places. It's very good to copy. A lot of students copy. I also copy. You have to copy a little bit in order to learn your craft. But then you look at the field and you find an area that not so many people walk around there, and you start walking towards it to discover what's there. Copying is good to learn, but then you have to go to the area where there is not so many people.
I want to say thanks everyone for coming, because this like interdisciplinary experience very, very important. Like because nowadays, although we know like AI, especially deep learning, data-driven, deep learning based methods is very wildly popular. But I always wanted to say, every problem in the world is not. We do not only have one solution to that. We have more solutions. So I think this kind of interdisciplinary studies is like to help us to have more ways, at least we can say like one more way to think about the problems in the world, and we can provide a different perspectives, to the problems or whatever in the world. Yeah, thank you.
Thanks everyone for coming. And also, thanks everyone for coming for the exhibitions and also for coming for the panel discussion.
Everything? Okay. Okay, and because we are making the end of the panel, and we'd like to invite Professor Chu to give us some
panel, and also from very diverse background, like computer science background, from art background. So we see actually that we learn a lot from our students. So even they are students, but actually they have many years and they practice in art or whatever. So a great learning experience. As Professor Zhang mentioned, this is just start point. And we start from here, then we go to the world, and more we'll see this kind of event on campus. This is exactly the purpose. So this campus have 17,000 students. I think Guangzhou will be equally sized. So two campuses, they have about 30,000 students. Then they definitely want to provide some kind of the art education and get students involved. That also have strong humanity side on this art tech. That's something we want to actually further to enhance in the future. So yeah, once again, I said, okay, these are real heroes of the exhibitions, and we put a lot of efforts, and also this panel give a big hand.
To wrap up, I'd like to emphasize the significance of our panel and this exhibition in fostering collaboration and the innovation between our campuses. So the insights shared today is not only let us understanding what is computational art or what is by our ALife, also encourage further exploration for us to go further research and studies. So I hope everyone have learned something today, or just have a good story, memories, or have some words in your future collaboration. Yeah, I will thank everyone, professors, and
Thank you.
thank all of you. Because I know it's very difficult for you to stay here, and yeah, we have to do our best to let you here stay and talk more interesting things. Okay, thank you. Hope we have a very happy